Before we dive into the epic journey of mathematics, let's take a moment to appreciate how math is more than just a subject taught in school. It's an essential tool that permeates our daily lives. Math is a universal language, transcending cultural and geographical boundaries. Whether you're in Pakistan, the United States, or anywhere else, the principles of math remain consistent. It's a common thread that binds us all. Think about your everyday tasks. We use math constantly without even realizing it. From grocery shopping to cooking, tracking finances, and calculating travel time, basic math skills are essential. For instance, when you're cooking and baking, understanding measurements and fractions is crucial for following recipes perfectly. Or if you're counting calories, math helps us track the nutrients in our diet or exercise routines. Time management, something we all struggle with, also involves math. Calculating when to leave home to arrive on time is a simple yet vital math function. And let's not forget financial literacy. Budgeting, saving, and making significant life decisions like changing careers or buying a home all require math skills. But math isn't just practical, it's also fantastic for our brains. Solving math problems exercises our brains and improves cognitive skills over time. It's a case of use it or lose it. Math also enhances our problem-solving skills. Word problems teach us how to extract relevant information and manipulate it to find solutions. These skills extend beyond math class and enhance critical thinking. Even if your child doesn't pursue a STEM career, abstract math hones critical thinking skills. It contributes to success professionally, emotionally, and cognitively. Mathematical knowledge enhances logical reasoning and mental discipline, which also aids understanding in other subjects like science, social studies, music, and art. So, as we embark on this journey through the history of mathematics, remember that math is not just about numbers and equations. It's a fundamental part of our daily lives, shaping how we interact with the world around us. Now let's dive into the incredible journey of mathematics, the queen of sciences, and discover how it shaped the world we live in today. Imagine a world without numbers, equations, or even the basic concept of counting. Difficult, right? Well, let's dive into the incredible journey of mathematics, the queen of sciences, and discover how it shaped the world we live in today. Our story begins over 5,000 years ago in the fertile lands of Mesopotamia and Egypt. Imagine the ancient Sumerians and Egyptians, who used mathematics not just for trade and taxation, but to unlock the mysteries of the stars and the rhythms of the seasons. The Plimpton 322 tablet, a remarkable Babylonian artifact, holds a secret. It knew the Pythagorean triples way before Pythagoras himself. Speaking of Pythagoras, let's fast forward to ancient Greece around the 6th century BCE. This is where mathematics transforms from practical calculations to a true demonstrative discipline. The Greeks, led by thinkers like Pythagoras and Euclid, began exploring the abstract beauty of mathematics. Euclid's Elements, a collection of geometrical proofs, is still a cornerstone in the world of math today. But mathematics didn't just flourish in Greece, far from it. The Romans, while not as theoretical, applied maths to engineering and architecture, building an empire that stood the test of time. Meanwhile, across the oceans, in China and India, scholars were making strides too. The Chinese introduced negative numbers and place value systems, while the Indian scholars developed the numeral system that we use today, later adopted by the Arab mathematicians and introduced to the Western world. Each of these civilizations contributed a verse to the grand poem of mathematics. From ancient abacuses to modern computers, from the sands of Mesopotamia to the stars above, mathematics is not just a tool, but a language that has continuously helped us understand the universe and our place in it. So next time you solve a math problem, remember, you're not just crunching numbers, you're part of a millennia-old tradition of explorers and thinkers. Now that we've journeyed through the rich history of mathematics, let's take a moment to meet the incredible minds who have shaped this fascinating field. These individuals from various periods and cultures have left an indelible mark on the world through their groundbreaking contributions. First up, Pythagoras, 570–490 BC. The ancient Greek mathematician is best known for the Pythagorean theorem, which relates the lengths of the sides in a right triangle with the famous equation, a squared plus b squared equals sine c squared. But did you know that Pythagoras also founded a school in Croton, where his followers, known as Pythagoreans, believed in the mystical properties of numbers and even proposed a heliocentric model long before it became widely accepted? His work forever changed how mathematicians understand triangular relationships. Next we have Euclid, 265 BC, often called the father of geometry. Based in ancient Alexandria, Euclid's foundational textbook, Elements, unified and expanded the mathematical theories and geometric understandings of his time. Many of his theorems are still used today. Interestingly, there's little personal information about Euclid, leading some scholars to speculate that he might have been a collective effort by a group of mathematicians. Then there's Hypatia, 355 and 415 AD of Alexandria, the first well-documented female mathematician. She made significant contributions to mathematics, astronomy, and philosophy, and her legacy continues to inspire women in STEM fields. Tragically, Hypatia's life was cut short, but her impact endures, reminding us of the importance of diversity in mathematical thought. Moving forward in time, we encounter Sir Isaac Newton, 1643 to 1727, an English mathematician and physicist who revolutionized science. His work on calculus, the laws of motion, and universal gravitation laid the groundwork for modern physics. Newton's famous quote, "If I have seen further, it is by standing on the shoulders of giants," acknowledges the contributions of mathematicians who came before him. Carl Friedrich Gauss, 1777 to 1855, often referred to as the Prince of Mathematicians, made significant strides in number theory, algebra, and statistics. His work on the distribution of prime numbers and the method of least squares remains influential to this day. Gauss's contributions extend beyond mathematics. He also made significant advances in physics, astronomy, and geodesy. And finally, we have Leonhard Euler, 1707 to 1783. A Swiss mathematician who was a prolific genius. Euler made groundbreaking contributions to graph theory, number theory, and calculus. Euler's formula, EIP plus 1 equals sine 0, elegantly connects 5 fundamental mathematical constants. His work laid the foundation for many areas of mathematics and physics, and his legacy continues to inspire mathematicians today. These titans of mathematics have each added their verse to the grand poem of mathematical discovery. Their contributions have not only advanced human knowledge, but have also inspired generations of mathematicians to explore the infinite possibilities that numbers and equations offer. So, the next time you solve a math problem, remember, you are standing on the shoulders of these giants. Now that we've journeyed through the rich history of mathematics, let's pivot to the present and dive into some of the most tantalizing unsolved mysteries that continue to baffle and inspire mathematicians worldwide. These aren't just abstract puzzles. They are the frontiers of human knowledge, waiting to be explored. First up, the Birch and Swinnerton-Dyer Conjecture. This conjecture deals with the enigmatic world of elliptic curves and their associated L functions. Imagine a beautiful, intricate dance where the number of rational points on an elliptic curve is intrinsically linked to the behavior of its L function. Proving this connection remains an open challenge, a riddle that has stumped some of the brightest minds. Next, we have the Hodge Conjecture. This one takes us into the realm of algebraic cycles on complex projective varieties. It posits that specific classes of cohomology can actually be represented by algebraic cycles. Despite significant progress, a complete proof remains elusive, making it one of the most profound puzzles in modern mathematics. Now let's talk about the Navier-Stokes existence and smoothness problem. These equations describe fluid flow, something as commonplace as water in a river or air swirling around us. But the question is whether solutions to these equations exist for all time and remain smooth without any singularities. This problem has confounded mathematicians for decades, and solving it could revolutionize our understanding of fluid dynamics. Then there's the P versus NP problem, perhaps the most famous unsolved problem in computer science. It asks whether every problem whose solution can be verified quickly, what we call polynomial time, can also be solved quickly. The implications of solving this problem are staggering, potentially transforming fields from cryptography to algorithm design, and we can't forget the Riemann hypothesis. The Riemann zeta function, crucial in number theory, has non-trivial zeros that are believed to lie on a specific line in the complex plane. Proving this hypothesis would revolutionize our understanding of prime numbers and number theory as a whole. Finally, the Yang-Mills existence and mass gap problem. This theory describes fundamental forces in particle physics. The big question here is whether a mass gap exists for the associated particles. Solving this would deepen our understanding of the universe at its most fundamental level. These are not just theoretical musings, they are the cutting edge of mathematical exploration, each one a beacon calling out to be understood. So the next time you ponder a math problem, remember you are part of a grand tradition of explorers, pushing the boundaries of what we know and what we have yet to discover. Stay curious, keep exploring, and who knows, maybe one day you'll be the one to solve one of these great mysteries. Until next time, goodbye.